Uh, Hello, everybody. I'm Matjaž Glavan. I came from Biotechnical Faculty of University of Ljubljana. And I will present a little bit about water quality and water quantity in relation to climate changes. We've done one small study, but we've done also other analysis of our water resources. So, you can go further. So climate change impacts on the water resources are numerous. You see here different causes that climate change can actually do. So it affects also to droughts, floods. It changes the groundwater levels. It changes the water quality, and also affects especially agriculture as a main source of production is actually water. So without water, there is no agriculture, in fact. In the last years, we've seen a lot of pictures. These pictures present different, for example, there is a picture of the world where it's showing the change in annual river discharge. It shows that different parts of the planet will get different amount of water in the future because the climate will be warmer. It means that there will be more evaporation, and that means a lot of more rain in certain areas. But this water has to come from somewhere, so the winds will blow this water to the north or to the south, to different parts. But it's not so clear picture, as I will show later. You also see here down a picture that shows where is more blue. It shows what will be on the. This is an annual precipitation at the end of the century. It shows that the north should get more rain and the south less. While in the summer part, is more yellow, it shows the summer precipitation at the end of the century. As we learned in the past years, it's not so. The average is not so important on an annual basis, even in a seasonal basis. We've seen this year a huge drought in the northern part, but climate change says there should be more rain in some sort of way. So it's a mixture of different situations that happen around the globe. We also seen this kind of pictures from this year that shows where the majority of the climate changes was happening. And also what really interesting picture here is that shows the highlights of the summer 2008. You saw that Spain, normal heat in autumn, seasonable weather. So Spain is somehow, it's like adopt in a way already because he had experiences with the bad weather, so droughts. While in the north they say it's a severe storm, it's a severe drought. It's a real problem for them to cope with that. And I think that also European Commission acknowledged this in the past calls that especially Central Europe, Boreal region and Pannonian region will suffer from dramatic climate changes, which was in the past few years observed in extreme winds, in extreme hailstorms, in extreme floods, in extreme frosts in the winter, extreme winter ice storms also in Slovenia. So we had different kind of weather on an annual level. So what we did in Slovenia to adapt to the climate changes that are ahead, we analyzed all our water sources. So we checked all our groundwaters, surface waters, and on annual level for the past 30 years we calculated how much of water we actually have. As a country with quite a lot of water resources, we are quite rich. So our agriculture shouldn't suffer from drought if we would have like reservoirs that we would catch the water in the winter. So we also calculated how much of agricultural land we can actually irrigate with this water, and there was plenty of water. Unfortunately, our politicians, they say a lot of things when there is a drought. Also, the farmers are very loud when there is a drought, but drought is every 3 to 4 years. So next year they already forget what actually they were saying last year. We then also, there is a problem in certain parts of the, 1/3 of Slovenia in the middle is a karst region. So there is not a lot of surface waters, and also the groundwater resources are are scarce. So we decided to do this kind of, to account for the potential winter surplus of precipitation, to retain water in a surface retention reservoirs. So you don't need like a surface river. You can also retain water from a hill above your arable area, for example, and you keep this water in reservoirs up to 5,000 cubic meters. So we did the kind of maps. So they are actually, the farmers are already look at them because they have problems in orchards in the spring with the frost, and also then in the summer they need a good quality product, so they need water. Especially with small fruits like strawberries, this is also important for small farmers. And then we also made a drought threat indicator. So these colors that you see, this is arable orchards without grassland. So it's arable orchards and vineyards. So this is all, we say, like agricultural land that actually can be intensifiedly produced in Slovenia. So it's not a lot. We are the third last agriculture country in Europe. So we only have like 0.24 hectare of agricultural land per inhabitant, and only 0.08 hectare of arable land per inhabitant. So it's quite very low. We are a very hilly country. So we did a small study also how the climate change would affect the river water quantity and quality if we would use different downscale climate models. Because we know that there are different groups in Europe who do a different kind of climate models. They use different kind of data. And we were just curious what would happen if we would apply these models. So we downscaled them to 1 point to the weather station in a small agriculture catchment. In the northern Adriatic, it's on the border with Italy, with a very strong orographic effect of different extreme events. It's mostly vineyards in that area, but the temperature range absolute is between -15 to +40 almost in this area, and it has quite a lot of precipitation, 14,000 millimeters. That's because of the very strong orographic effect. So what is also important in the area that we have a flysch soil, so it's a very soft soil that are easily managed, and that this catchment is actually a representation in comparison of forest and agricultural land as is in Slovenia. So in Slovenia we have 60% of forest, and this catchment has 56% of forest. But the forest is quite takes a lot of area in Slovenia. So here you also see different maps. Luckily, we were under Habsburg monarchy, so Austrians for many centuries, and they were very good in tax system. So they made a lot of different parcel maps, so they were very efficient. And we have 200 years back maps showing what kind of land use was there. These white spots on the first, it's a Venetian Republic. It was not under Habsburg monarchy, so. And it's quite important when you're explaining the climate changes, and the fact is also important that you take in account the land use that land use that could actually be in the future, or the management that will be applied in the future, because if you only talk about climate changes and at the current state, it's not the whole story at the end. Okay, we gathered a lot of data, and also all these 6 climate models from Swedish, Denmark, and British group, and so on. And we modeled the catchment with the SWOT model, soil and water assessment model. It's one of the most used models in the world. And then we also had to downscale all the regional climate models. So we have, on basic, we have these global climate models, and then regional climate models, and then you have to downscale it to a certain point. And on this picture, you can see the difference. So the raw data, so the regional climate model, it's in orange, and the blue, it's data that was downscaled. So you see that there are differences that actually that are important when you're downscaling. It's important that you pick certain point. So this is then how the different models will react in the future. You can see that there is, in the minimal and temperatures will rise, but the precipitation, it's quite mixed in this area. We are in the border between Mediterranean and the Central European and continental climate and Alpine climate. So a lot of different weather system is mixing here. So it's quite not clear what will happen in the future. Although now it goes everything to the it's moving to the area where they say there will be more rain, especially these extreme weather events. So we then calibrate, and we got some results. There were a few pikes that were not matched in this modeling exercise. And what was the reason is that they had this area is quite intensively managed in terms of making terraces. So they in this time of year they did a lot of different terraces, and when there was a weather event, there was a lot of soil washed. Although all the vineyards in Slovenia are grassed, it's a best management practice that everybody has to accomplish during the management. So we then run the models and compare it to the base scenarios. And in the first 30 years, we've seen that there will be a raise in the total water in the area up to 35%. Then in the second period, up to 60%. And then in the last period of the century, we've seen mixed results. There will be less or more. Who knows? We'll see. It's somehow, we can say also, it's a fortune telling in a way, because the weather, it's not a stable condition in a way. So we also then, sorry for this, it's a lot of numbers, but what is important is that even though the models are saying there will be less or more river flow, so total water in the area, when we look on the sediment, so total nitrogen or total phosphorus, in each case scenarios, there will be more leaching of nitrogen, there will be more erosion. It doesn't matter if it will be less or more rain. And this actually tells us that there are some seasonal variation in the data. When you look on different months, you see that in certain months there is quite a huge amount of rain. So it means that there will be more erosion because of the extreme weather events. Even though there will be on total annual level less rain, it will still mean that the surplus of phosphorus or nitrogen or erosion will be higher because of these extreme events in the area. And this is for nitrogen and phosphorus. In certain scenarios are quite going out of the box of the current situation. And then we also said, okay, if we translate this result to the concentrations in water, we already see that already in the current state there is too much of sediments if we comply to the fish directive and so on. So they will have to do something about that. And even majority of scenarios says that there will be more sediments in the future. Although some they also said it will be less. It's really, really tricky then for the policymakers to do any good strategy when you have mixed results. And what is also important, not only climate changes and what the state said, is also what municipality says. There is a lot of regions in Europe that they face with abandonment of the land use, of the land. The farms are closed down because there are bad connections and so on. And then usually this municipality, also this in Goriška Brda region, they have a spatial plan and strategy where they say that they will, in the future, have more agricultural land, and it will be managed in a characteristical cultural way so that they will attract more tourists, because the area is similar to the Toscan area, and it's some sort of a plus for them for the development of tourism. And if there will be more agriculture, it will also mean in this area there will be more sediments in the future. So on one side we have climate, then we have land use policy, and in the middle is water quality, and we have to decide what to do. So what were, at the end conclusion of the study were the decision need to be discussed in depth with all different sectors, and not a single climate change model reproduced data with the same average monthly values. It is not as clear as it might look on the first picture that there will be more rain. Okay, it means we have to adopt to tackle the floods in that area. And there is also no straightforward answer on the methodology, how to design research process when you are actually tackling climate changes in the area. Sorry. And what is also important that policymakers and decision makers should not really buy on technical reports of one sector, but it should be integrative way, because because usually politicians make political decisions, and they see what the general public thinks about, and also what will bring the most economical value to the area. But that's not the answer anymore in this situation. So I would also like to finish now with a comparison what European Commission is doing also. We know that Fertinova, we know the results and that they are eager to optimize water nutrient efficiency. We are also part of our group, a project called Fairway, which is dealing with drinking water and how to optimize farmers' management, and also the governments. The problem that European Union has, that there is a lot of research done in the whole community about climate change, water quality, but this is not transferred up to the European level, and that's one of the problems that also the European Commission observes, especially when you have horizon projects, how they are used. This is one also of the main problems in the future. And this year, next year, in the February, it will be also a new call on integrated water management in small agriculture catchments, which means that they somehow trying to, it will be especially made for the Pannonian, Central European, and Boreal regions. And they are seeing how to manage the drought, the floods, and climate changes, and also how to recover nutrients from the streams that are in bad quality. And also how to actually help farmers to use this kind of small retentions to help them in the future to cope with the climate changes. And let's hope that climate changes will go in the direction that even Almeria maybe someday like this. Thank you very much.